Soyuz launch to the International Space Station. This is Richard Hollingham in mission control at Korolev near Moscow, where I can tell you that all systems are nominal for launch in just over 40 minutes at 13:16 GMT. In fact, exactly 13:16 and 15 seconds GMT. That's 17:16 here at Mission Control, 19:16 at the Baikonur Cosmodrome in Kazakhstan, and that's where you can see the Soyuz spacecraft on the launch pad. Beautiful clear skies, beautiful clear evening in Baikonur. The temperature around -17 Celsius. Inside the Soyuz capsule, ESA astronaut Andrei Kuipers. He'll be spending 148 days in space. That's almost 6 months during his PromISSe mission. It's the 4th European long-duration mission to the International Space Station. Alongside him in the capsule, NASA astronaut Don Pettit and the commander of the Soyuz TMA spacecraft, Oleg Kononenko. Before the launch, we'll see Andrei in training and hear about the final preparations for this mission. Well, I'm not here at Mission Control alone. With me to commentate on events, ESA astronaut Paolo Nespoli. Now, Paolo, I was here this time last year commentating on your launch to the International Space Station. You returned in May after 159 days in space. Good afternoon. It must be a bit strange being here.
Yeah, good afternoon. Well, actually, it's pretty interesting. I would say that looking at the pictures coming from Baikonur, I remember what we were doing about a year ago, and it's very nice now to see behind the curtains here what happened here to make all this happen.
So what's going on in the capsule at the moment and on the launch pad at the moment? Shortly before we came on air, we saw the service towers. It comes in two parts, retracted.
Yes, so for the last couple of hours, the astronauts have gone through the standard preparations, which is just putting on their space suit, making sure that it is sealed and everything is working correctly. Then they went all the way to the launch pad, went up in the capsule, and they essentially position themselves in there. There's only a little hatch, so the squeezing 3 people in there takes quite a long time. There's a tight, precise sequence, and then once you are all in there, the hatch is closed, and then there are a few more checks, making sure that the capsule is tight. Suits are again checked, making sure that suits are tight, and then in sequence they just activate all the system up to the point, little by little, up to the point when in a few minutes they will actually be ready to take control. The Soyuz spacecraft will be able to take a fully autonomous control and actually lift off in space.
And as we look at the Soyuz there on the launch pad, anyone familiar with the American rockets? With the Russian system, at the top of that, that's not where the capsule is. They're actually slightly lower. There's the escape part right on the top. Then it's the orbital module, and then they're actually beneath that.
Well, yes, the Soyuz spacecraft is actually encapsulated and enclosed into this shell that protects them when they go in space. It's composed of 3 pieces, as you said, and it's currently encapsulated into this system, which is part of the escape system. So if there would be any problem right now, if something would be catastrophic, there would be anything happening, then the tower, the 3 rockets that are inside the tower will actually activate, detach the white top part, all the white part all the way to the green is the actual Soyuz orbital part. All of that will be detached, will go up all the way to about 20 kilometers, and then the regular re-entry sequence will take place until they will actually land back on Earth.
I should just explain where we are. We're in the International Space Station control room. There are 2 of these. There's one here and there's one at Houston in the United States. The Soyuz itself, the control room for the Soyuz is only a few meters away from us, just behind the wall behind us. So the view you can see at the moment is of the International Space Station control room. That's where we are. We're in a balcony overlooking that view at the moment. Well, before the launch, we'll be catching up with Andrei's training, but I think we can have a look now at the preparations the crew has been making for this mission since the 1st of December. as Palsy. Palsy?
GCTs, the crew and some of the training people are actually brought down to Baikonur, and this is when they actually enter the quarantine. In Baikonur we are in this complex which is kind of isolated, and it starts, the quarantine starts with the first day actually putting the flags up of the nation represented in this endeavor.
So that's the crew and the backup crew you just saw.
Yes.
And I think this is the first time they got to actually step inside their spacecraft.
Yes, 10 days before the flight, more or less, they actually go inside the spacecraft, make sure that everything is okay. They check that everything has been done. You know, there are some patches of Velcro, some other things that are placed inside. So they check that everything is there to their liking. If there is anything to be changed, that's the moment to talk.
And then the same thing, get in with their spacesuits, and then it's a visit to the museum, sign the wall. All cosmonauts have signed the wall.
Yeah, there's you know, there are a lot of things that are traditional, and we all do this, and sign the wall, sign doors, sign the rocket, and then we go away, and they actually complete the installation of the Soyuz itself on top of the rocket. This is that part that shows that part.
And this is where it all comes together.
Yes,
It's
exactly.
enormous assembly building.
Yes, this is the assembly building down here in Baikonur. This is the first stage, second stage, third stage, and the other one is actually the third stage. So this is all mated together. This is all of this long, enormous, heavy lifter. Only the upper part will actually go in space. The rest will actually come back to Earth.
I think you get a sense of the scale there. I like the fact it's big bolts that holds it all together.
Those are big explosive bolts. They are explosive because they need to really be tight and hold up the spacecraft, but at the same time, when they need to open, and that's why the best way to do this is making sure about blowing them up, but make sure that really they open up when they're supposed to.
Now this is the rollout to the pad, which takes several hours, and the whole assembly, the whole launcher, is taken out horizontally on a train.
Yes, this assembly building is only a few kilometers away from the launch pad, and in this building is where all the final assembly is done. But then a couple of days before the launch, the rocket is put on the train, and then slowly, almost at pace, I mean a walking pace, is brought to the launch pad, and is actually almost thrown into the launch pad, because 2/3 of the rockets are, or 1/3 of the rocket is actually below the ground level there. So it's pretty impressive and interesting seeing how this is done. It's very effective, and it's amazing that they can do it in this way. You know, we are used to, at least we are used to the shuttle where the spacecraft is brought on the launch pad in a month before launch, and all these things. This just goes there almost few hours before the launch, and it's amazing how everything gets together so quick and so nicely.
It is a beautiful vehicle, isn't it?
I would call it, I'm not
You're
sure
not
I'd call
gonna
it
say beautiful.
Well, no, I'm not sure about beautiful or not, because, you know, this is what is beautiful, what is not.
Oh, I think that's beautiful.
I would say the characteristics of this vehicle is that it's relatively simple. It's relatively small. I mean, inside of the spacecraft there's not that much space. It's small, but it's very reliable, and it takes you to space. No kidding. I mean, it takes you up there and it brings you back, and this is what it's supposed to do, and it does it in a very reliable way. I mean, so it's really interesting. See, it's always amazing how this rocket goes inside this thing. So it's just and it's just sitting there. I mean, it's not really even bolted to anything. It's just sitting there in a kind of a balance stage, balance state until the rocket actually, the engine lift up, light up, and then it's lifted in space.
And that's snow falling off that, if you wondered. And look at that on the launch pad. And we're back in the control room here at Korolev. In a few minutes we hope to bring you some video shot in the last few hours at Baikonur with the final crew preparations and seeing the crew getting in to the spacecraft. They are inside there now. You can see that those service towers have been taken away. They've just tilt downwards. That happened a few minutes ago. It's worth remembering, I think, Paolo, that Soyuz is now the only way to get people to the International Space Station.
Yeah, that's correct. We used to go with the space shuttle, but this is not available anymore. And everybody, American astronaut, European astronaut, Japanese, Canadian, all the astronauts of the space station actually use the Soyuz to go up there.
And just while we can see it there on the launch pad here, live pictures from Baikonur, just talk us through from the bottom to the top. The bottom, some people call them the strap-on boosters, but they're the boosters that come out of the side. That's the stage one.
Yeah, we don't see them in these pictures because they're actually almost below ground. I mean, at least 1/3 of the spacecraft is below ground level here. There is a kind of a hole in there. It's kind of it's called a flame trench, where the flame is actually taken and directed away from the structures and sensitive parts. That is the stage one, which is composed of 4 strap-on boosters plus 4 more engines inside the Soyuz.
So that's beneath the shot at the moment. Then you come up. Stage 2 is the, if you like, the stick in the middle.
Yes.
Until you get to that join part, which we can see in the middle of the shot.
And it's very interesting, by the way. If you look at this picture here, you see that the bottom part is white. And actually, that bottom part is not white. It's green, and it looks white there. And there is a joke there. We say that somebody came during the night and painted the rocket white. In fact, that's ice. That white thing, it's ice that condensate around that part of the tank, which is super cooled, and that's why there's all this ice around.
Well, we can see inside the capsule, inside the spacecraft now. Obviously, one of the cameras, one part of the capsule is obscuring one of the cameras, but we can see the final checks now.
Yes, we are about 30 minutes before launch. This camera view has on the bottom left the commander, and on the upper right Andrei, and actually shows the Soyuz commander and the board engineer number 1. This is the standard camera that is shown usually during the Ascent.
So Andrei is on the left of the commander?
Is sitting on the left on the commander. That is the one that is now saluting, and it's the that position is reserved for the flight engineer number 1. It's actually the co-pilot. He is responsible with the commander to make sure that the vehicle perform nominally, and in case of problem, they will actually take control. Both of them will actually take control of the vehicle.
And then to the right of the commander, NASA astronaut Don Pettit, and we can't see him in this shot.
Yes, on the right, they will probably show him later. They usually actually show the second camera halfway through the Ascent. 3 minutes, from 3 minutes to 5 minutes, they show the other camera, so that we can see also flight engineer 2, which is almost a seat of the tourist. It's let's say the scientist. He's part of the crew, of course, but it does not have any real active role during the launch and entry.
There we go, the Soyuz on the pad at Baikonur. This is Richard Hollingham and Paolo Nespoli at the main control room at Korolev near Moscow, where the launch is in 27 minutes, due in 27 minutes. So what about this mission? What about Andrei Kuipers' mission? It's been named PromISSe and forms part of Expeditions 30 and 31 to the International Space Station. Here's a report with some more details.
This second mission is very different than the first
No,
one.
you're talking
It's,
perfectly.
6 months instead of 11 days. And that also means that the role will be very different, because on the first mission I was specialized on the Soyuz, and then in the space station mostly on doing experiments. Now my role is more operational, so I will have to do a lot more in the space station itself, like maintenance and repairs, but also I'm trained for working with the robotic arm, spacewalks, and we should not forget that the space station is now twice as big as during my first flight, so that's a completely different job.
You have to take them out.
Andrei Kuipers has been researching the effects of spaceflight on human physiology with the European
So he
Space
said we
Agency.
were
Which is
sticking with the
positive.
plan.
Just one positive reinforcement, Chris.
During his stay on board the space station, he'll be continuing
So we're sticking with
his
the plan. We'll
long-term
have this one
program of
and,
microgravity experiments
Group 5.
inside the European Columbus laboratory. This module, which was added in 2008, provides facilities far beyond those available when Kuipers made his first flight. Just one of the reasons he's keen to return to orbit.
I was disappointed that I had to leave already after 11 days. I wanted to enjoy microgravity more and see different places, and so then I thought I want to fly again. This is very special, and so therefore I decided that I would of course volunteer for the next mission again.
Okay, that's great.
Whilst Kuipers is on board the space station,
Chris, 5 minutes before the
Spacecraft
launch,
crew will be
they actually
visited by ESA's Automated Transfer Vehicle, or ATV. This unmanned supply craft is particularly important now that the shuttle has been decommissioned, as it can ferry large quantities of equipment and supplies to the International Space Station. As flight engineer, Kuipers will oversee the automated approach and docking of the spacecraft and carry out unloading and repacking operations. He's also been trained to implement emergency procedures if any part of the docking goes wrong.
ATV is a very big cargo ship. It's fantastic. I have the training here now, not only in the approach, but also how to handle the cargo and how to install it and afterwards use it for trash. The third one is going to arrive during my increment, and of course the crew has an important task in the last part of the approach to be sure that we get a good approach and good docking.
The mission will be Europe's fourth long-duration stay in orbit. It will be an important time for ESA, generating a whole host of new scientific data and providing crucial operational experience for the future.
Well, it's now just under 24 minutes to the launch of Expedition 30 to the International Space Station. Let's bring you up to date with what's happening here at Mission Control and on the launch pad. It's looking increasingly, Paolo, like it's ready to go.
It is. I think everything looks pretty nominal. I see the crew there checking few data on the screens. They have completed all the activities that they need to do. There's only one thing that needs to be done, which is at about 5 minutes. They will actually close their helmet. And that's it. So in fact, if you see that this is the second camera we were talking before, the second camera, the one that you see on the left is
Right, so we can now see Don Pettit there.
Pettit with the American flag up there. The thing that you see on his left, those are all the board documentation. They will be opened up. They have on their lap the actual book that is needed for launch, but then when they go in space they will need other books, and those are the books. On the right we can barely see the face of the commander, but I'm pretty sure in a minute or so they will switch back and we will see the commander and Andrei Kuipers there.
Extremely crowded in there.
It is. It's a small spacecraft. We were talking before, and you told me that it's a beautiful spacecraft, and it kind of resisted a little bit.
It's beautiful to look at from the outside.
Yeah, from the outside. I would not say that beautiful is one of the characteristics of this spacecraft. I would say, though, it's extremely reliable. It works really well, and it's actually amazing how it can do things in a very simple way, but very nicely and reliably. Again, I would fly on a Soyuz anytime.
Now, we're in mission control here, just at Korolev near Moscow, and on the screens here we've got the pictures from the launch site itself. We can see inside the capsule. We've also got an idea of what's going on at in terms of the timings and in terms of the countdown. You can't quite see it in the picture there on the screen, but across the top there is all sorts of data across the top of the screen.
Yeah, these are the standard data that are used for the flight controller here to actually sync up on time. It's actually interesting. We use here a time that is not the standard Moscow time. It's a kind of a bureaucratic Moscow time. It's always funny looking at this. It's an hour off the regular time. In fact, on that one it's now 15:55.
Which is very disconcerting.
Which is disconcerting at the beginning with all this time. It's in the upper left for the one that can actually read that one. And then there is a bunch of data here. The most important are the time to connection or zvyaz, they say in Russian, so that the time we can actually talk to the TDRS, to the satellite talk-to station. And then on the right side we have actually the countdown to launch, which now is 20 minutes and 30 seconds and counting.
And this is the control room for the International Space Station. It's a mirror of the control room in Houston. So we've got the actual position of the space station in here. The next room, just behind us, is where Soyuz is controlled, but controlled really when it's in orbit. It's up to the crew to make sure it gets there after launch.
Yeah, I mean the Soyuz goes in a kind of automatic way. The crew on board actually checks all the parameters and is ready to take control in case of a problem. In principle, the ground does not do any commanding up there, or very few commands. They actually read all the telemetry and have a very good insight of all the instrumentation and all the board mechanisms, and they can tell the crew to do anything. What happens also, the Soyuz spacecraft go in space, and then strangely enough, after the first burn, they actually shut down everything. It becomes an object that flies in space, and on the ground they actually follow it with radars to derive what is called the state vectors, which is essentially the equation that shows the motion of the Soyuz. So they can compare this to the state vector of the station and figure out how to do the sequence, how to burn in order to catch up.
So actually they have to do those calculations after launch. They know more or less where it's going to end up, but actually you have to say where exactly are we.
Because the engines are chemical engines, and the weight is calculated, and you don't know the density of the atmosphere can change. Even the wind can make a difference on where the Soyuz is going to end up. So they know more or less where it's going to be, but the precise calculation is done later using radars from the ground.
And on the control boards here at Korolev, you can see the events immediately after launch. On the board you may be able to see on your screens. On the board on the left-hand side, we have the launch at this is this slightly strange Moscow time. 16:16:14 is the launch. It will actually be 17:16:14 in Moscow. That's 13:16:14 GMT. It's very confusing.
What about Baikonur time?
I can tell you, it is in 18 minutes.
Exactly, that's what I will stick to. It's in 18 minutes exactly right now.
This is Richard Hollingham and astronaut Paolo Nespoli at mission control here at Korolev near Moscow. We're following the launch preparations for the launch of Expedition 30 to the International Space Station. Andrei Kuipers, PromISSe mission, and he's in the capsule at Baikonur, at the top of that Soyuz rocket, which you can see there at Baikonur. Alongside him in the commander's seat, Oleg Kononenko, and then in the right-hand seat of the Soyuz, Don Pettit, flight engineer with NASA, NASA astronaut, I should say, and flight engineer on this mission. The other two are flight engineers. So Andre's a flight engineer, and Don is categorized as a flight engineer, and then there's the commander.
Yes. So the crew up there, as we said before, it's actually the responsible for the flight is the commander itself, and he is able to decide what needs to be done. Of course, he has the flight engineer. Flight engineer number one on the left, which is Andrei, which is a co-pilot. I mean, Andrei has been trained actually to physically take control of the vehicle if necessary. He has all the capabilities in front of him, all the screens, all the buttons, and everything. And then on the other side there is Don Pettit, who's a flight engineer. It's called flight engineer because in fact he is a flight engineer, but the position, the seat where he's sitting, does not have many capabilities. This was formerly was the seats for the research cosmonaut or the tourist. Though I have to say that I've worked a long time with Don Pettit. It's quite a character. I mean, he is a physicist and engineer. He's almost a madman. I mean, he can build a nuclear reactor in his garage. It's quite a character.
It's amazing how dark it is now at Baikonur. Well, let's hear a little bit more about Andrei Kuipers. This isn't the first time he's flown in space, but despite his experience, he's had to put in many months of training for this latest mission. Let's have a look.
Andrei Kuipers from the Netherlands joined the European Astronaut Corps in 1999. A medical doctor with 2 decades of experience in space physiology, he underwent an 11-day space mission to orbit in 2004, traveling on board a Russian Soyuz vehicle to the International Space Station. Despite his experience, he's had to endure many months of international training to prepare for the task ahead.
Many years ago I flew for the first time, so you forget things that we have to refresh. But also there's a lot of new things. The station is now twice as big. We have of course the Columbus module now, that wasn't there when I flew for the first time. On top of that, the Japanese module, several nodes. Also on the Russian side we have new modules. So that means a lot more things to learn.
Kuipers' training has included stints in Russia, the United States, Japan and Europe. He's had to learn the intricacies of a huge array of equipment provided by the space station's international partners, and prepare for every eventuality.
These are sessions with the complete crew, but also sessions that I have to do alone. Nominal cases, but most of it is of nominal cases. For example, that I am the one who is going to approach the space station and manually dock it to the station. Probably will never happen, but I have to be ready for that.
At ESA's European Astronaut Center in Cologne, Germany, the Dutch astronaut has used simulators to train on the Columbus laboratory, in which he'll be carrying out a range of experiments, and the ATV, or Automated Transfer Vehicle.
It's exciting training because it's seconds, you know, you have to react in a short period. And you have to monitor a lot of different things to see if the ATV is approaching in the right way, because we have to, of course, protect both the ATV and the station that nothing happens. The real thing is going very smoothly. We have 2 dockings, and that was all okay. And of course, like most of the training, you train for unlikely but dangerous situations.
Thanks to high-tech simulators and experienced trainers, Andrei Kuipers has been able to perfect complex skills such as robotic operations and spacewalks on Earth, and is now ready for the challenges of living and working in space.
You can see now mission control and the board here at Korolev. near Moscow. This is the International Space Station control room. And then just behind us, just in the room next to us, is the Soyuz control room. At the moment, though, all the activity is taking place at Baikonur. It's now just under 12 minutes to the launch of this Soyuz. And already we've had the emergency escape system has been armed. The service towers, as you can see, have been withdrawn. A few minutes ago, the suit leak tests were carried out. And just 7 minutes before launch, the pre-launch operations will be complete. How much of this, Paolo, is automatic? And how much is controlled? Because there's no countdown. This isn't like a NASA launch.
Well, the crew work using a board documentation, which actually has time, and there are actions that need to be done on board. So this is a highly choreographed sequence of events, part of which are initiated from board and part of which are initiated from down in Baikonur. I remember we did many activities on board. We switched things, we turned on accelerometer. This is very important. For example, like I think the last actions that the crew does 35 minutes before the launch is actually to turn on the accelerometer, which means that the onboard emergency escape system can now start sensing, checking these accelerometers. If they sense there is a strange acceleration, which could mean, or usually means, that there is something going on with the rocket below, then they actually activate this escape system. So there is a lot of things that are really done on orbit, and they're really, on orbit, on the spacecraft, and a lot of that are really done on the ground. So they now actually gave the order or the command of the crew to start closing their helmet. This is done to make sure that the suit is completely tied and sealed. The suit is not pressurized during launch, but it can be pressurized in case there is a problem, there is a leak or something could happen, some kind of contamination, fire or anything like this. The suit immediately will pressurize in order to maintain a breathable atmosphere for the crew. And actually, we can see here, we just heard the flight controller from Baikonur reporting that the commander of the spacecraft, or the Soyuz, has confirmed that the helmets have been closed and everything is nominal.
And now we can see, yes, inside the Soyuz capsule now. This picture from the main control board here at Mission Control. And we're looking at Don Pettit there. You can identify him by his stars and stripes on his arm. So there are two cameras in the capsule itself, in the spacecraft. You can see both angles, but you can't see all three cosmonauts at the same time.
Yes, that's correct. And these are already wide-angle cameras. I mean, the whole inside of the spacecraft, I jokingly say it's about the same size of the back seat of a small car, and it's actually true. The big thing that you see on the right, the big bag on the right, this is actually something that is strapped on top of the container of the parachute. That's actually the main parachute in the back of that. And then on top, all the emergency gear, all the survival gear is actually strapped there, and it's used and open up in case of landing in a weird place.
So the equipment we're looking at, in fact, what dominates that shot is actually for the landing rather than for the launch.
Well, it is also used in launch in case of an emergency land or some kind of problems. Then the spacecraft could land anywhere during the launch sequence, and that contains survival gear that the crew needs to or could use in case of emergency. And then what you see on the upper left of the screen, that gray box there, It's actually the gas analyzer. Is the one that checks the content of the atmosphere, the amount of oxygen that is in there, and tells the inside system if they need more oxygen or less oxygen.
We can see again in close-up. This is the other camera, and there's Andrei Kuipers waving to us.
Yes. These are the last minutes. We are about 7 minutes from launch. I think there is nothing else to do up there more than preparing for launch and making sure everything's okay and say goodbye. It's actually very. I think it's at this point here, you're actually waiting for being launched. I mean, it's like, okay, I'm ready. Everything is ready. Let's just go. And it's pretty interesting. By the way, one thing that we see on the upper left, that's the second container for the emergency parachute, and on top of it there is also emergency equipment to be used in case of off nominal landing.
These are live images from Baikonur, the launch of Expedition 30 on a Soyuz TMA-3M in 6 minutes' time.
So we are about 5 minutes and 30 seconds from launch. There are some activities that are done at Baikonur. Some electrical plug have been removed in order to take away power and control from the ground. At this point, the Soyuz is completely autonomous, and all the internal system have been activated. And one interesting thing, so if you look at the scene from inside the spacecraft, you see that the cosmonauts or the astronauts have in their hands a book. That is called flight documentation. It's actually the Bible. You actually follow it on board and follow it through, making sure that all the steps that are written there are actually performed accordingly. And if there is any deviation, is then when you need to start working on it. That book, which is green, it's the book for launch and entry. In case of emergency, they will take out another book which is red, which is the emergency book. And one interesting thing, if you look at the right hand of the commander, you see a stick. It's now covered by the book, but you will see him using the stick. It's because the position of the commander, it's a little bit further down than the position of the flight engineer where Andrei is, and I'm pretty sure he doesn't need the stick. He can actually reach the control without stick, but the commander, being slightly lower, cannot do that, and it's very interesting. He's using the stick to actually actuate the control.
And how difficult is that under the sorts of acceleration they're going to experience?
Yes, it's pretty difficult because actually I would say that the Soyuz starts pretty slow. At the beginning you're kind of thinking, you're expecting some kind of a big jolt or anything like this, which happens with the shuttle. The shuttle is like a train comes on your back and pushes you off the launch pad. This one is very, very mellow, and so you can move your hands, move your stick and everything very easily. You pay all of this later when the acceleration starts building up, and towards the last phases of the 8 minutes sequence, acceleration gets pretty heavy, and there it becomes a little bit difficult to use the stick and actually point it and put it where you're supposed to go.
It's now 3 minutes and 20 seconds from the launch of Soyuz TMA-3M to the International Space Station and the start of ESA astronauts Andrei Kuipers' PromISSe mission, part of Expedition 30.
So what typically happens here is that all the inputs on the screen are done from the flight engineer, not by the commander. So the commander is actually supervising and things are done properly, but the flight engineer, since he can't reach easily on the screen, he does all the inputs. And it's interesting how in training you don't have all that equipment around you, so you can actually look at the face of your commander and making sure that everything's okay. And then you go on the real spacecraft and you cannot look at it because there is a lot of stuff in there. So you have to rely on the voice control. It's pretty interesting.
This is Richard Hollingham and Paolo Nespoli at the International Space Station Mission Control at Korolev near Moscow. It's now 2 minutes and 10 seconds away from the scheduled launch of this Soyuz from Baikonur. You can see it there on the launch pad.
Yeah, the attention is building up here at the control center. I see all the flight controllers sitting down, looking at their screen, looking at numbers. I see the crew, which up to now was moving freely, is now taking a position, start focusing on some of the parameters there on the screen, because this is what it tells us what is going on. Okay, and that next step shortly is about 1 minute and 10 seconds to launch. The umbilical will move away, and which means that the rocket is completely free. And then at about 6 seconds from launch, the engine will start building up, accelerating, or turning on the pump. I have to start working, and it will take 5 or 6 seconds until this have enough power to actually lift off the vehicle from the launch pad, which at this point is still pretty heavy.
And there with the umbilical cord. Umbilical cord? The umbilical tower, I suppose it is. That's something of an umbilical cord. It's now 30 seconds to the launch. We're going to pause our commentary here and, like you, sit back and watch the launch itself.
Very good. We are about 30 seconds into launch. All the system are operating nominally. And the commander confirmed that everything on board is going nominally. Yes, there is a confirm here from the control center that the engines, all engines are working nominally. Pitch, yaw, and roll are responding nominally, and first stage is going according to plan. It will take about 114 seconds for the first stage to burn. We are now about 90 seconds, so another 20 seconds until first stage. Seconds to the end of the first stage. Everything is nominal. Very good.
And these are live pictures you're seeing from inside the Soyuz capsule?
Yes. Everything here they are reporting that everything is nominal. The acceleration on the first stage went all the way to 4 Gs. We are told here from the control center, and now it's back to 1 G and climbing slowly. And they're now about to switch the camera. There it is, camera switch. You can now see the Don Pettit on the left and crew commander on the right. They will stay on this camera for 2 minutes, and then we'll go back again to the other camera showing the commander and Andrei Kuipers.
So we've had a successful first stage separation.
It
And there it
was
is, you can
nominal,
still
yes.
see it. Still see it over Baikonur, disappearing into a clear sky.
Yeah, we will see it. I mean, it's a clear day in Baikonur. We will see it for a long, long time. I mean, it was almost all the way to orbit, almost. I mean, okay, acceleration at this point starts build up a little bit more. We are now at about 2 Gs, which is about twice as much the regular weight on Earth. You can see the string up there on the left that is kind of tense under the acceleration, and it will build up more and more. In about 15 seconds they will switch back the camera from the left camera to the right camera. That's very good. So the third stage has been activated, and we were all the way to 2.5 Gs, then went back again to 1, and then we are at the last part of the acceleration, where we will climb steadily at a pretty good pace all the way to orbit.
And this is the live image from Mission Control. You can see in the top left-hand corner the cosmonauts and a NASA astronaut in the Soyuz.
Yeah, here from the flight control room, they confirm that everything is nominal, and we can see the pictures there on orbit. Everything looks really, really quiet. Nothing's going on. They are looking at all the numbers now, and you know, we've done hundreds of simulations where at this point things start getting weird. We get crazy, pull out the books and everything, and then it's kind of interesting. You are in space and you're waiting for something to happen to pull out the book, and nothing happens. It's very interesting.
So we're now almost 7 minutes into the mission.
Yeah, it's fairly interesting here because our count up here is actually in seconds, and that's the way they count here the functioning of the engine. It shows about 420 seconds into the flight. We will get all the way to 528, so another 100 seconds of accelerated flight before what is called KO, which is cut off, which is in English would be main engine cut off while we were in space. Acceleration has started building up again. We started from 1, and then now we are back to 2, and it will keep climbing. I remember this phase here gets a little bit uncomfortable when the acceleration, because you're sitting on the back, there's a lot of stuff on the back, everything gets squeezed, and it's here you really feel the power of the engine that they are thrusting you in space.
Now, if we look at this main screen, enormous screen here at Mission Control, we see lines dropping away from the main arc, which is the path of the Soyuz spacecraft itself. Are there stages separating off?
Yes, those are the parts of the vehicle that have been used and are actually coming back to Earth. And so they come back on an area that has been cleared and everything is under control. It's just showing us the sequence, that the sequence is going according to the plan.
And there we see Andrei Kuipers in the Soyuz. Everyone looking fairly relaxed at the moment, as much as I can tell through space.
Yeah, we still have 15 seconds to go. We are now 3 Gs and very good, 10 seconds to KO, to shut down the engine. We should see the images, and they actually jumping ahead, because when the engine shuts down, they cut away the image. There we go. Very good. They are in space. They are in space. They got all the, and we can hear the clapping.
Round of applause here at Mission Control.
Very good. We saw them shaking hands in space. They're now turning page because they have a lot of activities they need to do now.
I don't know about you, Paolo, but that just sends a shiver down my spine, and you've done this.
Yes, yes. Well, you know, it's pretty interesting because a lot of people here actually think, okay, this is done, and in orbit it's like, okay, now we start working, because up to now everything is nominal, and now they start they need to start punching things, you know, open valves. You can still see them starting open things, checking that everything is working nominally. The docking mechanism is starting being activated. The antenna has been deployed. So a lot of things that are happening right now, and the real work starts. I mean, what they need to do in the next hour and a half is the first burn, and there's no getting out of those seats until this is completed and the orbit is circularized, because otherwise there's still some kind of probability that they can come back to Earth.
And I don't know whether you can see that on the main screen. We can now see the position of the International Space Station and the position of the Soyuz. There's quite a lot of catching up to do.
Well, you know, the Soyuz and the space station are launched in the same orbital plane, and they are launched in a way that the catch-up that needs to be done is done in a way so that the Soyuz is not too close to the station, because it will be unsafe. It's not too far away, otherwise it has to spend too much fuel to get it. It's exactly in the position where there is a little bit of work to be done, but still keeping the safe distance, so that accidentally, if there is any problem, the Soyuz does not bump into the station.
But it takes 2 days to reach the space station. Why does it take 2 days?
Well, in fact, the Soyuz could actually dock earlier than that, but at this point, the Soyuz does not have any internal mechanism that can derive this state vector that knows where the Soyuz is. The Soyuz does not know. The ground knows. And so, because there are these variables that are due to efficiency of the engines, wind, density of the atmosphere, even the sun makes a difference. Because there are all these values, the controllers know more or less where the Soyuz is, but there are some ground stations on the ground, some radar stations that actually track the Soyuz, and they track it for several orbits until they can derive an exact state vector. And from that state vector, then they can actually calculate the exact burns that need to be done to reach the station. So the days that pass by, the orbits that are passing by, are so that all the mechanisms on board are actually deployed. Control, for example, there is already a control making sure that the docking mechanism is working. It gets exercised already now. There is a start now. The radar on board gets checked, and then this state vector is defined properly.
Well, they're now well on the way to the International Space Station. Very quick time to reach orbit, but now, as you can see from the top left-hand image, live images there from the Soyuz. A lot of work going on in the capsule itself. Well, last time Andrei Kuipers visited the space station, that's back in 2004, there were just 4 modules. Well, now it's complete, and the emphasis with this mission is on science. So I think we can hear a little bit more about what the International Space Station is now doing.
The International Space Station is now in its 11th year of continuous human occupation. With the major construction phase over, astronauts are able to devote more of their time to carrying out experiments and routine maintenance procedures. 2011 has nonetheless been a significant year in orbit for the European Space Agency. In May, Paolo Nespoli from Italy ended a 6-month stay on board the ISS. It was the 3rd European long-duration mission, involving an intensive series of experiments and the docking of ESA's 2nd ATV supply vessel. During his time in orbit, Nespoli was visited by another Italian, Roberto Vittori. Arriving in May, he was the last European astronaut to travel on board NASA's space shuttle, ending an era which began with the Space Lab missions almost 3 decades ago. Since the final flight of shuttle Atlantis in July, the Russian Soyuz capsule has been the only means of getting to and from the International Space Station. This will have a major impact on ESA's manned spaceflight program.
There is only one vehicle which is capable of transferring humans to ISS and back from ISS. So in that respect, it's a little bit an uncomfortable situation. However, the Soyuz launcher and the capsule in the past has been proven to be extremely reliable. I think we could ensure very well flights for the next European astronauts. We are also taking steps in the area of transportation that could help us, playing an important role in the future transportation aspects of exploration.
Much has changed since Kuipers' first flight to the station back in 2004. ESA's Columbus Laboratory and Cupola Observatory have greatly enhanced the working environment, and the number of pressurized modules has increased to 15 since the addition of the European Permanent Multipurpose Module in February. The station is now in its utilization phase. Over the coming years, the international partners will concentrate on reaping the rewards of their investments in orbit.
ISS has been now in orbit for about 11 years, and there are at least 9 years more to come. All international partners have agreed to run the station at least till the end of this decade. However, I'm sure that on the 31st of December 2020, neither the station will disintegrate nor there will be any less demand in using ISS as a scientific platform.
Paolo, this is video you shot as you were leaving the space station.
Yes, this we were really lucky because we were the first crew, the first Soyuz leaving the space station with a shuttle attached. This was never done before, and we were lucky to be able to do this. And we were lucky that the space agency allowed us to stop at about 200 meters away from the station and take these pictures. It was just magnificent to see this, the station up there. It looks like a dream. It looked like something almost unreal. So nice it was.
I was at the launch of the first stage of the International Space Station, the Zarya module, and to think that it's gone from that single module launched on a proton rocket to this enormous structure with these giant solar panels, and to be assembled in space. I think it's easy to take for granted the size of this and the achievement in building this in orbit.
Well, it's obviously it's the biggest structure that we have ever built in space. It took more than 30 space shuttle and another dozen of Soyuz proton heavy lifter to bring up all the pieces up there. It's pretty amazing. It's as big as a football field, and it's interesting how these pieces, with each one of them is big as a truck, have been built everywhere around the world, and they just get together in space with a precision, not even millimetric, micrometric precision in space. It's pretty amazing.
Here we can see live pictures from space. This is the crew of the Soyuz capsule. You can see, I think, a sense that they're in orbit now. We just saw a pencil floating around. Not a great deal of space to float, though.
Yeah, but what is really interesting here is that they have opened their helmet, and that is a sign that they have double-checked the pressure inside the spacecraft, that everything is holding, everything is nominal, and therefore they actually opened up the helmet. That's a very important step, because if you don't do this, then there's something wrong, and instead here it's going, everything is going nominally. I can see them. There is actually a smile up there, a grin on Andre's face. So I think we lost the images there, because I was actually pretty amazed that we still had the images there, because these are images that are sent to ground by a ground station, not by a satellite, and to have the images for
even
such a long time.
20 minutes after launch.
Yeah,
I think
20
that
minutes.
I've not seen them for
Yeah,
that long
exactly.
before.
Usually we lose them pretty quick after them. Let's see where the Soyuz. Yeah, that's why the Soyuz is essentially now over Japan, so it's outside of the reach of the ground station over the older Soviet Union, because Russia still maintains some of the stations that were scattered around the Soviet Union.
But we saw Andrei Kuipers in there with his checklist, helmet open, ready to work. And Andrei will spend 148 days in space. If you think that's a long time, well, a team of experimenters has just returned from a 520-day mission. Okay, so they weren't actually in space, but the Mars 500 participants have certainly endured more than their fair share of hardships. They emerged in November after completing their trip to Mars and back, all from a simulator in a Moscow suburb. Let's have a look at some of the highlights.
He's all relaxed.
He's making a cocoa.
First thing that I will do when we open the models will be hugging my family and spending time with them. Then I will call my friends, asking them what has been going on since I left. In general, I miss a lot the randomness of the world. We had received a lot of emails and a lot of Twitter messages that improved our spirits and made us a little bit more happy. When we opened the Mars lander, it was filled with a lot of items, food, clothes, and hardware, a lot of different things, and so it was like Christmas. With the headphones that you put on your head, can hear the sound of birds, the sound of the wind, all the nice things that you hear when you go walking in nature. We have them here, and we have this virtual environment which helps us cope.
Не торопись, супруг, не торопись, помаши рукой всем, по очереди.
After 520 days of motionless trip, we are proud today to prove that human can go to Mars.
Well, that was Mars 500 in just over 3 minutes. They spent 520 days in that experimental space station and that simulated trip to Mars. Paolo, this is important, isn't it? That this understanding long-duration space flight and the problems, the challenges.
Yes, it is really important. In fact, ESA was one of the first agencies thinking about this. I remember in 1990, I was I was the crew of one of the first simulation. It was only 30 days, which was long at that time. And the idea was to actually figure out what happens with a crew, which is isolated in a confined environment without capability of contacting the outside. And obviously here with this people, Mars 520 days, and they were actually simulating going to Mars. You know that Mars is about 50 million kilometers away from Earth, which means that about a month into your flight to Mars, you start getting some kind of sense of being far away, because the communication, the radio communication, don't happen anymore instantaneously like now, like we have on the space station. So if in space station we have a problem, we can actually call Houston or Munich for that matter. We sleep at night, and 150 controllers check the parameter of the station and send command, and barely, I mean, in my 6 months in space, they woke us up once only. These guys, they have to do everything by themselves. I mean, it's pretty amazing. This is really remote now. It's you and the spacecraft which is keeping you alive, and understanding all of this and the interaction between the crew, it's really, really important.
And I think people forget that. They think perhaps it's easy to think. I think we all probably think, well, look, we've been to the moon. We're in orbit now with the space station. Can't we just go to Mars?
Well, going to Mars is a different ball game. I mean, again, as the moon, it's about 300. Well, space station is 400 kilometers away. We get to orbit in about 8.5 minutes. The moon, it's about 350,000 kilometers, which means that in 3 or 4 days, 5 days, we can actually go there. Mars, contrary, if we take one of our rocket today, it will probably take 8, 10 months, 12 months, a year, close to a year to get up there, and then another year to come back, and probably a third year to stay up there. So it's about 2.5, 3 years trip. It's really a different ball game. I mean, we are outside of the Van Allen belt, which means that radiation is really strong from the sun, and if there is a solar event, the crew and the spacecraft will fry. So we need to figure out how to protect ourselves from this kind of events. So there are a lot of things that we need to do and learn. And last but not least, having you know, a good crew, a good sized crew, I don't know, 6, 10, 12 people for up to 3 years in a spacecraft. They have to have everything they need: food, clothing, water, oxygen. They need to not to be bored at the same time. They need to have some time off. They need to keep fit from a physical point of view. You know, they always say that if you want to take some good friends and make them enemies, just throw them in a boat and have them cross the ocean. Well, can you imagine what happens if you cross the solar system and go to Mars and come back? I mean, this is really, really something that cannot be taken lightly. And today, it's probably at the edge of our technological and physiological capabilities.
Now, Andrei Kuipers is due to spend 148 days in space. You spent, I think, 159. Is that right? What did you learn? 150. Was I right with that?
Yes, that's
yeah.
correct.
So what did you learn from that experience?
Personally,
personally, in terms of the long duration space flight?
Actually, I was amazed because I thought before flying, I should be honest, thinking that something like, I must be out of my mind, 6 months in space, are you crazy or something? I thought it would be really long. I thought I would be bored. I thought there would be a moment in which I would simply be wanted to be back on Earth, and that, to my amazement, never happened. I mean, there was never a dull moment. I was always involved in doing things. I really, really liked what I was doing. It was challenging at times. It was a little bit frustrating sometimes because, you know, microgravity, it's a very interesting environment. You can get really thrown off, and it takes really a month and a half before you learn what to do or what not to do, how to behave. But after that, I think it was really enjoyable. In fact, I think both myself and Katie Coleman, the American colleagues that rose up with me, would have stayed another couple of months, no problem up there. So I learned personally that we can do this. And it's actually enjoyable, and it's actually very useful, both from us and from the international community and the space community.
What you just saw there was one part of the launch today. Before that, you saw the empty launch pad at Baikonur. That's exactly the sort of picture that we wanted to see today. An empty launch pad, the cosmonauts and astronauts safely in orbit.
Yeah, and you know, it's very interesting there looking at the launch pad, because this is the same launch pad that was used 50 years ago from Yuri Gagarin. I mean, pretty amazing. The diagram that we see here now, it's essentially the activities that will be done on orbit. From the launch, you see the first orbit, the blue one, the one.
So we see the launch right at the top from Baikonur,
exactly,
which we see labelled at the top, and you see that that line coming up to the first of these the concentric circles.
Blue circles. The first one is actually the orbit where they are right now, and then they will do 2 burns to bring them to actually change the altitude of the station and sorry, not the station, of the Soyuz, and approach the altitude of the station. So there will be 2 big burns that will take place, and they will actually change the altitude of the station, and then there will be a series of little burn that will actually bring the Soyuz little by little close to the station. It's actually interesting because you know, the station is flying around the Earth at 28,500 kilometers per hour, which is, you know, about 7 kilometers per second, and the Soyuz needs to approach it at a speed of 28,500 kilometers per second plus 7 centimeters per second. So this is done in a very controlled manner, because, you know, orbital mechanics works in a different way. If you try to accelerate in space for some kind of reason, you actually change your altitude, and so it gets a little bit disconcerting when you actually look at the effect of these burns from the engines.
So you can't simply go faster, because then you'll end up going higher, and then you'll miss what
Well,
you're
actually,
aiming for.
it's funny, because if you, you know, suppose you are on a freeway, you have a car in front of you, and you accelerate a little bit. If you want to overtake the car, you just push on the accelerator, and you go left or right, whatever you are in UK or not. You move away of the path of that car, and then you pass it. Well, in space, if you have the station in front of you and you simply accelerate, you end up going higher and back. And if you brake, you end up going lower and forward, which is very disconcerting, and it's pretty interesting, and it took quite some time.
So here's the launch again, spectacular nighttime launch from Baikonur this evening.
Yeah, there are very few words that can be said here. I mean, it's pretty impressive. As I said earlier, the Soyuz launch starts fairly slow, little by little, and picks up steam or picks up the pace later on in the upper part of the atmosphere. Right now it's pointed straight up. You want to cut through this dense layer of the atmosphere as soon as you can. The spacecraft is enclosed into this shield so that it can slice through the atmosphere with minimum resistance. All the engines are burning there, and let me see, I think there are like 20 engines going here, if I'm not wrong. Actually, it's 5 by each, 25 if I'm not wrong. So it's a collection of engines there burning and bringing the spacecraft up in space. I'm always kind of joking, say that going in space is like sitting on a small nuclear bomb that explodes in a kind of a controlled manner. So all this energy goes down, and as a result, you are thrown in space. But this is exactly what happened. I mean, the amount of fuel and energy that needs to be generated in order to lift off the spacecraft is just phenomenal.
We're very lucky with the clear day. There's been snow. It's minus about 17, probably colder this evening at Baikonur. And that's stage 1 separation.
Exactly. At this point, the strap-on booster go away. The Soyuz starts going a little bit more horizontal. In fact, you saw some of the stars passing by there. In fact, was the rocket going a little bit more horizontal, because what is important here is not so much going up straight, but is getting orbital speed with respect to the Earth. So you kind of put yourself horizontal and you accelerate it, and this acceleration brings you in space.
Well, we have been waiting to hear from some of the VIPs at Baikonur, the Director General of ESA, Jean-Jacques Dordain, Thomas Reiter, the ESA Director of Human Spaceflight and Operations, and Frank Devin, ESA astronaut. They're all at Baikonur for today's launch. We're not going to be able to hear from them in the next few minutes, but they will be carried on our satellite transmission as soon as we have them. So we're going to end our live coverage and our program today, the coverage of today's Soyuz launch. ESA astronaut Andrei Kuipers, Soyuz commander Oleg Kononenko, and Don Pettit from NASA are now well on their way to the International Space Station. I'm Richard Hollingham. Thanks very much to Paolo Nespoli here, who's been with me at the Mission Control Center in Korolev near Moscow. Thank you, Paolo.
Yeah, it was a pleasure to be here, seeing the activities down here, and live again what happened to me a year ago. Andrei is going to be in space for 148 days. His adventure, his work, actually, I would say, just started. I know he has plenty of activities to do, a lot of science, a lot of research to be done, a lot of technological experiment, but a lot of educational activities. He's planning to really talk to schools, use this experience to really push our young students, our young people to really follow a dream and work and get enthusiastic about space and technical things. And he's also going to use a lot of social media, social network to send us down pictures and keep us updated of what is happening up there. And we are really looking forward to be with them, support them, and learn a lot.
And you can find details of all those activities on the ESA website, and we'll be talking more about those during the docking and opening of the hatches between Soyuz and the International Space Station. That takes place this Friday, the 23rd of December. The docking is scheduled 15:20 GMT, that's 19:20 here in Moscow. The hatch opening is scheduled for 1800 GMT and will be on air from 1500 GMT. Don't worry if you can't remember all those times, they will also be on the ESA website. Thank you very much for watching.
We'll be watching the NASA Internet website on your progress feed. Bye now. Hey Don, here we are in Arizona, and you are eating, and have fun in space, and happy holidays. Beaming you up, Scotty. Bye. Hi, can you hear me badly? Thinking of you, and we know you will have...
Oh, we have work to do. Yes. Forgot about it.
1098-7654-321. 1098-7654-321. Tax solution.
Hi, Bill Gerstenmaier. Bill, on a brutally cold night, a successful launch to cap off a memorable year. Your thoughts on the Soyuz taking off of the station?
An absolutely amazing sight tonight to watch the engine start up and come to full power, and to see the rocket lift off, and then to see the glow of the rocket against the snow on the ground was just absolutely phenomenal. I can't think of a better way to really kind of cap off this year as this wonderful launch. There's still a lot of work in front of us as we get ready for the rendezvous and the docking. But what a great way to start. What a great testimony to the Russian teams that can work in these kind of conditions, and a wonderful rocket that did its thing and really got the crew on its way to space station.
Dan Burbank and his crewmates get a Christmas present here in a couple of days. How critical is it to restore the six-man crew on a steady state basis up on station for what lies ahead?
You know, I think as we look ahead, the big focus on space station is research and doing experiments. There's some really nice combustion experiments that are getting done on board, and to get this crew up and get the full crew complement up on board to do more research will just be outstanding. You know, some of the first work they'll do is they have some computer change out to do, some card change out in the computers to upgrade the processors in the computers. That work will get started around the 28th, and that'll be pretty busy. And then, you know, we'll roll into a progress launch, and then another commercial cargo launch potentially in February of the Dragon capsule. So just a tremendously busy increment as it starts out, and it'll be great to have all 6 crew members on orbit working together.
Okay. All set? Okay. Mike Seferdini. Mike, Dan Burbank and his crewmates up on orbit get an early Christmas present with tonight's launch. Your thoughts on the cap-off to a memorable year?
It has been an incredible year with the final shuttle flight coming and with all those supplies on board. We've transitioned to really a big utilization effort, and research, of course, being in the forefront today, and we're looking for commercial adventures in the future for ISS. And so, you know, this period where we went down to a 3-man crew for a short period of time, we really did see the impact in terms of how important it is to have a full crew on board ISS. So, yeah, I think Dan and company are going to be very happy to receive their crewmates, and we'll be excited about getting them back to a full research capability on board.
You see the next half year on station as a turning point, sort of a new era in the way station will be operated?
Well, you know, we've transitioned really the thought process that we do utilization first and operate the laboratory or maintain the laboratory around that. We've made that transition about a year ago, and we've been operating that way. This particular increment is going to be interesting because as we staff back up and get on with research, we do have some pretty unique things going on still on board. As was mentioned by Mr. Gerstenmaier, you know, we're changing our computers to a new version of computers. That's going to take time. We're bringing in on our first commercial vehicles going to show up. Not only do we have that, we've got a Progress and an ATV coming up in the first 3 months along with a Russian EVA. So we still have all the normal things we do on board ISS and still want to make sure we have the right amount of time dedicated to research. So I'd say we've always been doing research, but I'll tell you, it's now with our dedication to getting the average of 35 hours a week on board, it's more challenging now to do the other things that we normally have to do.
Does it still make you amazed that they can launch in this kind of brutally cold weather?
Well, the last launch I couldn't see anything because it was so snowy. This one, it's almost too cold for humans to be outside. So yes, it's an amazing vehicle. I mean, that's our Russian colleagues should be commended on building such a robust system, and it is. It's even in warm weather, it's amazing to see the vehicle fly as reliably as it does.
Thank you, Mike.
artificial pregnant and raise up because it's going to freeze. Yes. And that was three first of the play.
Yes. It's me. It's you.
It's okay. What does this represent for you, this Soyuz launch here?
Oh, it's another fantastic mission where we have on board one American, one Russian, and one European going together to work with their crewmate for 5 months on board the space station. So it's for all the partners, but in particular for ESA, a very important event. And if I add that this is the crew who will welcome in March the 83 Eduardo Amaldi, I think that again we shall have on the space station crew, hardware and experiments which demonstrate the interest of the space station.
The Soyuz also is an incredible vehicle. It was in Kourou, plus 30 degrees, now in Baikonur, minus 25, 30 degrees.
Yes, it's incredible to have had last Friday night, a launch of Soyuz from French Guiana, and today the launch of Soyuz from Baikonur. So it's 50 degrees of difference, but the same reliability, and it's a very good launch.
ESA DG is happy.
Very happy. Very, very.
Thank you.
Okay, thank you.
Okay, so Thomas Reiter is the director of human space flight operations in ESA. What is your feeling about this Soyuz launch here?
We just witnessed a fantastic launch. It's a clear night in Kazakhstan, a little bit chilly, minus 20 degrees. We could follow the launcher until third stage separation. We know the crew is now in orbit, getting ready for closing up to the station, and of course we are looking forward to the next half year where the guys will be working hard on the station to do all the scientific experiments and their tasks.
These long duration flights are very important for ESA.
Yes, indeed. It's actually the 4th time that an ESA astronaut has a long-term flight on board ISS. It's a continuation of our utilization program. Of course, André is not only working for ESA's program, but with the international partners to fulfill also their scientific tasks, and it just signifies another step in this international cooperation.
You started this long duration as an astronaut, so what do you feel about this situation now?
It's a kind of strange situation to witness now from ground, but I can very much relate to what the crew is now doing in orbit. I had some time on ISS, and now I'm following that from here, and I will do all my best that André will have the good conditions to do his work, and of course that the other ESA astronauts who are getting ready for their flights in the next years will have good conditions to perform their training and then get to the station.
Okay. Thank you very much.